Hello, everyone. Thanks so much for joining today's webinar on the HAProxy 2.3 feature Roundup. My name is Daniel Corbett, and I'm the Director of Product and Marketing at HAProxy Technologies. So first, let's get started on the subject of connection improvements. There's been quite a bit of low-level work completed, and foundational improvements have been made that will pave the way for quick and HTTP3 support within HAProxy. So first of all, the connection layer was optimized to reduce the number of syscalls, and several debugging entries were added to help spot anomalies. The listeners have also been reworked, and related structures have been reorganized to suit this new design. And so now, everything needed to register a quick protocol layer based on UDP should now be in place. Apart from this, HAProxy now gives you some more control over the Linux TCP Keep Alive feature. For those of you who are not aware, TCP Keep Alive lets the Linux kernel know when a peer on the end of a connection has stopped responding and when it's safe to close an idle connection. It discovers this by periodically sending probes, and if the peer does not reply after a specific number of probes, the socket is closed. In some cases, you may want to specify the interval, the idle time, or the number of probes that are answered before dropping the connection. Typically, though, these values need to be adjusted using the sysctl parameters. But a potentially undesirable effect to this is that it would then apply to all of the processes running on the system. So HAProxy 2.3 now supports tuning both the client side and the server side TCP Keep Alive parameters. You can adjust the interval, the idle time, and the total number of probes sent with the following options that can either be specified in the front end or back end, depending on whether you're attempting to adjust the client side or the server side. All of them are also able to be specified directly within a listen or a default section, and they'll apply where relevant. So a major and quite exciting change in this release is that you can now create a syslog listener over UDP or TCP and Unix sockets as well, but we'll be focusing on UDP and TCP. This allows you to forward syslog messages to a pool of UDP or TCP syslog servers. You can also prioritize these messages by having HAProxy look at the priority for each message and send certain priorities to certain servers or backends. For example, maybe you want critical priority messages to go to a pool of syslog servers that you use specifically for collecting alerts and issues from your services. Sampling allows you to forward 1 out of every 10th syslog message to your backend syslog servers. Keep in mind, that was just an example. Sampling is highly flexible and completely customizable, and it ties in nicely with prioritizing because you could choose to sample info messages, but maybe you don't want to sample alert or higher. You can also translate messages from one format to another. So, for example, if your syslog messages are coming in with different formats, you can centralize them and translate them to RFC 5424 before sending them on. To support all of this, a new section has been introduced named log forward. And this is where you will configure the bind and backend syslog servers. This section also supports a new UDP bind keyword named dgram-bind. A new runtime API counter, cum receive logs, has been introduced to show the info command, show info command, which provides a global count of received syslog messages. So this is just an example configuration for the new log forward section. Keep in mind, I'm not showing all of the possibilities here. There's a few other things that you're able to do, but I just wanted to give a high-level view, an example of how you could use this. So in this example, we're accepting new syslog connections on both TCP and UDP over port 7514, and then we're translating the messages to RFC 5424 and forwarding them on to 4 backend syslog servers that each have a defined sample rate of 1 in 4 servers, 1 in 4 messages per server. Sorry about that. So some various load balancing improvements have been made for several of the algorithms. So first, we'll start with the top, where some inconsistencies were reported when using the balance URI directive between requests received on HTTP 1 and the same ones being received on HTTP 2. This is because HTTP 1 puts the domain information in the host header, but it keeps the URI path within the request line, and HTTP 2 puts everything in the headers. So one of the challenges this introduces is creating a uniform hash of URIs when incoming requests have a mix between HTTP 1 and HTTP 2. So to solve this, a new option for balance URI was introduced, which is path only. And that indicates that the hash should be calculated using only the path of the request. This normalizes HTTP 1 and HTTP 2 requests. And improvements were made to some of the other load balancing algorithms as well. So the random algorithm was improved so that if the server selected has reached its max con value, the request will then be added to the backend's queue and not the server queue, meaning that it will be redispatched to another available server. The algorithms round robin, static round robin, least con, and first were also improved in a similar fashion so that if a request had been queued in the backend due to a previous attempt at finding a suitable server, then the next request will go directly to the backend queue. In a test environment, this change increased the request rate from approximately 110,000 requests a second to 148,000 requests per second. So you might be able to see some substantial improvements, but keep in mind that's within a test environment. The least con algorithm was improved to take the queue length into account when dispatching requests. This means that if a server has a lot of queued requests, HAProxy won't hammer it with extra connections. So the HAProxy cache was introduced in 1.8, and it's seen continuous improvement since. This release adds support for the expires header, which instructs HAProxy how long it should cache the response. It also adds support for the eTag, if none match, and if modified sense headers, and can return an HTTP status code 304 indicating not modified instead of the full object. The configuration parser will now also reject cache sections that contain duplicate names. Two new handy fetches have been introduced. Both of them are based on response objects, so res.cachehit, which can be used to indicate whether a response came from the cache, and res.cacheName, which will return the name of the cache that was used. So HAProxy 2.2 introduced the capability to load SSL private keys separately from the certificate through the SSL load extra files global directive. However, it required that the key be named the exact same as the certificate with the .key extension appended to it. So for example, if you had a certificate named mycert.crt, the key had to be named mycert.crt.key. But maybe in some cases, you want the key to be named just mycert.key. So HAProxy 2.3 has introduced a new global directive, SSL load extra del ext. And this keyword instructs HAProxy to remove the extension before adding the new .key extension. However, keep in mind that it's not compatible with bundle extensions, ECDSA, RSA, or DSA. So a very powerful but rarely talked about feature in HAProxy is its ability to dynamically generate SSL certificates on the fly when provided with a CA certificate and its private key through the generate certificates keyword. HAProxy extends this capability and will now add a subject alternative name or SAN to all generated certificates, which is a requirement for modern browsers. It now also supports chaining CAs and attaching a trust chain in addition to the generated certificate. The chain can be loaded from the one provided in CA sign file directive. So that's a great change. And HAProxy also supports, as many of you know, end-to-end encryption, allowing you to accept TLS connection from a client and then terminate that request and then re-encrypt the connection and connect to the backend servers using TLS. It also allows you to specify the host name that's sent when you're using the TLS SNI extension. However, when specifying the SNI on the server line, the connection is marked as private, and therefore that backend connection wouldn't be shared or reused. In most cases, though, it was found that most users are hard coding the SNI as a string, and they're not using a dynamic log format parameter. So in those cases, HAProxy will no longer mark the connection as private, allowing it to reuse the connection as there's no risk in reusing the connection with a hard-coded SNI. So many of you know HAProxy is known to provide best-in-class observability into the traffic that passes through it. With over 100 measurements available through the show stat command, it's able to measure error rates, track queue lengths, and connection counts, and much more. And with that said, there's a growing need to continue to improve the amount of statistics and metrics that can be pulled from HAProxy. This release introduces stats contexts, which allow for extending the default statistics. This will allow various components to register their own counters, and the two new contexts that are supported initially are based around HTTP2 and DNS. These will allow you to get detailed information from the connection level of HTTP2 and also gain insight into the activity behind the resolver section of HAProxy. A new directive, stats show modules, has also been introduced that will add additional columns to show additional proxy-related statistics. Currently, it adds additional information on HTTP2. The stats page also now has a new field under the weight column that will show both the live and the live or the effective weight and the configured weight. This is helpful when you're using the slow start directive, where the effective weight may be different than the configured weight. So as mentioned, the runtime API command showStat has been expanded to support context. You could change context using its new option, domain, and it's also introduced a new dash delimiter, after which additional dynamic fields can be added. They're referred to as dynamic because they won't be shown unless the relevant component is in use. So simple monitoring systems that are used to just looking at the core stats, whose comma-separated fields are documented within the management guide, can stop when they encounter the dash. And intelligent systems that can match a column according to its key name can then get everything after the dash. ShowStat now also adds two additional parameters, up and no maint. These are helpful when you have a large pool of servers configured using the server template directive, as they will only show the servers that are either up or not in maintenance. It will also show the ratio of servers that are seen as healthy. For example, 7 out of 10 configured servers are healthy. The native Prometheus exporter has been expanded to include some new process and server metrics. So from the process level, you'll now be able to collect information such as the number of failed DNS resolutions, the total number of bytes submitted, as well as the bytes out rate over the last second. On the server level, you'll be able to get the current number of unsafe or safe idle connections, as well as the current number of connections in use. So distributed tracing is a method used to profile and monitor applications, especially those built using a microservices architecture. Distributed tracing helps pinpoint where failures occur and what may have caused poor performance. OpenTracing provides an API specification that allows developers to add instrumentation to their application code. In conjunction with the HAProxy 2.3 release, HAProxy Technologies has released a new OpenTracing SPOA that allows HAProxy to send data directly to distributed tracing systems such as Jaeger through the OpenTracing API. There's several improvements and other options that are intended to be introduced in future releases, so stay tuned if you're interested in OpenTracing. Two new HTTP request actions have been introduced. The first is HTTP request replace path queue. It's similar to its counterpart, HTTP request replace path, except that the replacement value may contain a modified query string. The second one is HTTP request set path queue, which it too is similar to its counterpart, HTTP request set path, except the query string will also be rewritten. Several new fetches have been introduced. Path queue allows you to extract the URL path with the query string. As covered on the previous slide, res.cachehit and res.cache_name will return whether a response was served from cache and also provide the name of the cache it was served from. Serve iWait and serve uWait will return an integer corresponding with the server's initial wait and effective wait, respectively. SSL cdir chain and SSL s chain dir will return the formatted chain certificate presented by the client and server, respectively. And then a new converter was added. if. It's gonna take some getting used to pronouncing that one, which is an abbreviation for immediate if. It's similar to a ternary operator and allows you to use one string if the evaluation is true and another if the evaluation is false. This is helpful for passing HTTP or HTTPS in the X forwarded proto header, or using the new res.cachehit fetch to set an X-cache header containing hit or miss. Support for Lua 5.4 was added. This release also exports the sample fetches HTTP auth and HTTP auth group. You can also use regular expressions in fetches and converter arguments. And this means that regsub converter is available. However, keep in mind, map converters based on regular expressions are not available because the map arguments are currently not supported. Also, with this release, sample fetches and converters that require arguments are now supported as well. Many changes have happened to improve cross-OS support. So Dragonfly BSD was added as a build target. FreeBSD, NetBSD, and OpenBSD have been expanded to support various build parameters, most specifically for those mentioned, except for and get adder info are now supported, and each of their respective versions have also been bumped. The support for Solaris has its version bumped to 10, and also we've added support for the TCP compiler. So some obsolete keywords that were previously deprecated have been officially removed in this version. The first two are monitor net and mode health. These can both be simulated with the new native response generator through the HTTP request return action. The next is the global keyword debug. You can still use the debug functionality by passing the -d argument from the command line, so keep that in mind. And then two keywords have now been deprecated. The first is NBproc, which is scheduled to be removed in HAProxy 2.5. All users are recommended to move to threads. And if you have any concerns about that, you might want to voice them on the mailing list, but it's highly recommended that you start moving to threads if you haven't already. Keep in mind as well that after HAProxy 2.2, threading is automatically enabled out of the box, and HAProxy will automatically scale itself across all available cores out of the box. So the other deprecated keyword is Grace. It's set to tentatively be removed in HAProxy 2.4 with a hard deadline of HAProxy 2.5. So thanks for joining the webinar. Follow us on Twitter at HAProxy, or you can join us on Slack at slack.haproxy.org. If you want to ping me there, I'm also available. My name is D Corbett on that Slack. I'll be happy to talk to you about anything that was presented here. Thanks again, and I hope you all have a great day.